Hello and welcome to my new video. Today we are digging into obfuscation, what it is, why Android applications use it, and how it changes what you see in the compilers like JADX. I'll show you some practical examples with R8 or ProGuard and custom rules. So let's start. Obfuscation is a common technique widely used in Android development and in software development in general. It's the process of modifying class names, variable names, and sometimes even the app structure to make the code hard to understand for reverse engineers. Both legitimate and malicious developers use it. Attackers use it to hide harmful logic, while legitimate developers use it to protect the sensitive code and data from being stolen. In fact, Google's official documentation recommends using obfuscation as a part of app hardening to protect application from tampering and reverse engineering. Obfuscation can be done in several ways in Android. The simplest way is using ProGuard or R8, which automatically renames apps, classes, methods, and variables to meaningless names. Some applications go further and use custom obfuscation, manually replacing names and strings to random symbols. For reverse engineers, obfuscation doesn't make analysis impossible, just slower and more confusing. When you see unreadable class names or strange function calls, that's a strong hint that the code has been obfuscated. For the beginning, I've created a very simple one-class application where you can see several methods that create string and int values which are set as text values and text use. From the developer's side, these methods look very simple with understandable names. Let's generate an APK and have a look at how this code looks when we open in JADX. We can see that most packages still have normal names, and we proceed to our package. We open main activity and see that the code actually looks very similar from both developers and reverse engineers' perspectives. However, many local variables were removed or inlined. For example, variables inside methods were removed, sample unused variable in onCreate disappeared, and sample used variable was inlined directly into the log call. That happens because of code optimization performed during the build by R8 or ProGuard and later by dexing, which applies optimizations and inlining. That functionality is on by default, and you generally cannot and have no reason to switch it off. But most of your code remains the same, methods name are still present and so on. Now let's have a look how we can enable obfuscation. In Gradle build files of our app module, under Android build types, you will see minifyEnabled. By default it is false. Setting it to true enables code obfuscation, shrinking, and optimization. And also note this line: get default ProGuard file, ProGuard Android optimized.txt. It means that build uses the standard Android optimization rules. And just a quick note here. Even though we see the word ProGuard in the Gradle file, modern Android builds actually use R8, which replaced ProGuard a few years ago. R8 performs the same tasks: code optimization, shrinking, and obfuscation, and it still understands ProGuard rule files. So whenever we talk about ProGuard rules or ProGuard config, we are really talking about R8 reading those files. Let's now generate an APK and open it. First, let's take a look at the app structure. You will see many packages with non-human readable names, letters and numbers. Remember, our sample APK contains just one class we created, main activity. So these packages are obfuscated generated code for libraries and SDKs. This is why there are many obfuscated packages. You may ask why system or library packages are obfuscated, but main activity and the app's package name are not. It's because the standard keep rules preserve classes referenced from the Android manifest. Because the manifest cannot be obfuscated. If main activity was renamed there, the system wouldn't find it and the app would crash. Let's now look at our class. Here much more code was inlined and many of our helper methods were removed. That happened because the build used ProGuard Android optimized.txt and aggressive optimization removed or inlined simple code. Since major part of our code was simplified, it's harder for you to see how obfuscation changed the names. To see obfuscation more clearly, we will switch from ProGuard Android optimized.txt to just ProGuard Android.txt in Gradle. This uses less aggressive optimization and will not remove or inline our small methods. Let's create a new APK and open it again in JADX. The default generated code looks similar and package names are obfuscated in the same way. Let's inspect the main activity again. Our methods were not removed because of optimization, and now we can clearly see how obfuscation worked. Method names are no longer readable and are replaced with short identifiers like C0, D0, and so on. That's how basic obfuscation works. Of course, this app is very simple and remains easy to understand, but I intentionally made it simple so you can clearly see the mechanics. For production apps, obfuscation makes reverse engineering much harder, especially when the app is large and call chains are complex. Now let's look at one more thing related to obfuscation. In the Gradle ProGuard files method, we also see the reference to ProGuard rules.pro. This is an automatically called file present in every Android project, unless removed manually. This file can be viewed from the Android project files menu, and if we open it now, we can see that it contains standard comments explaining how to use it. Generally, this file is needed to make exceptions for obfuscation. For example, to specify classes or packages that should not be obfuscated. You should never obfuscate logic related to serialization, because if it gets obfuscated, it will not work at all. That is because serialization requires exact matches in classes and fields names. The same applies to the code which relies on reflection. One more thing that can be done in this file is defining custom rules for obfuscation, and we will now look how it works. I created and put 3 text files in the app folder: classes, members, and packages. These files contain thousands of randomly generated gibberish strings, which will be used by R8 or ProGuard as obfuscation name sources. Now let's create an APK with these rules and inspect it. When we open this APK, we immediately see that most of packages are heavily obfuscated. If we open any random class related to automatically generated code, we can see that the identifiers look gibberish and it becomes difficult to read the code. Even our simple activity now has methods and classes names which are hard to read. From my experience, legitimate applications are usually using standard obfuscation settings, while custom obfuscation is used by malicious applications trying to hide malicious logic. So that's it for obfuscation, a way to make code harder to read and understand. If you like this video, please put your like and subscription, and don't forget to turn on notifications. I have more practical reverse engineering topics coming soon. Thanks for watching.